Hello, in this video we're going to talk about Newton's second law. So let's start just writing it down. Newton's second law tells us that the net force on a system is equal to mass times acceleration. Newton's first law basically told us that forces are what caused accelerations, and this tells us that the proportionality constant is what we call mass. In effect, this is what defines mass. So m is the mass of the system, which means that mass is an object's resistance to being accelerated. Objects with large mass are hard to accelerate. Objects with small mass are easy to accelerate. It turns out that mass depends on how much stuff an object is made out of. Basically, you can count the number of protons and neutrons in an object. Every proton has the same mass, and every neutron has the same mass. You add those all up, and that gives you the total mass of an object. Nonetheless, this is I guess you could say, the more fundamental definition of what is mass. Okay, well, the net force is a vector. Okay, so we want to work in terms of components. In other words, instead of having a single vector equation, we'll have a scalar equation for each component. Let's just say that there's two components, x and y. So the net force in the x direction is equal to the mass times the acceleration in the x direction, and the net force in the y direction is equal to the mass times the acceleration in the y direction. So more typically, what we would do if we have equations involving forces and accelerations is we break them up by components. It's also worth mentioning that the units of force are defined using Newton's second law. So the units of force is equal to the unit of mass times the unit of acceleration, and I'm using square brackets here to represent units of, so read these as units of. Units of force are units of mass times units of acceleration. Units of mass are kilograms. The units of acceleration are meters per second squared. And we could call the unit just kilogram meter per second squared, although forces are so common that we write another unit for it that we call N, or newtons. Okay, so 1 newton is 1 kilogram meter per second squared. For reference, a newton is about the force that you push a doorbell with. So newtons range from much smaller than 1 to much, much larger than 1. Something like, I don't know, breaking a bone would be 10,000 to 100,000 newtons for that to happen. Depends, of course, on which bone. But, well, let's not be too morbid. All right, anyway, next time we're going to look at setting up problems using Newton's second law. So, see you in a little bit.